Hey guys, so today we're going to go over the quotient rule, which is when you're finding the derivative and your original function has one function of x being divided by another function of x. So in this case, I'm going to call f of x, which is my numerator, the first function of x, which is 5x minus 2. And my denominator would be the second function of x, which I'll call g of x, which is x squared plus 1. So notice, just like the product rule, you have to know its derivative in order to apply the rule itself. So to find f prime of x, I'm going to apply the power rule to each term. So 5 times 1 is 5. And then if I take 1 away from the power, it would give me x to the 0 power, which I'll leave out. And then the derivative of any constant would just be 0, so I'm not going to write that either. And for g prime of x, coefficient, if you don't see it there, it's going to be 1. 1 times 2 is 2. If I take 1 away from the power, it gives me x to the first power. And the derivative of any constant would be 0. So I don't need to take the derivative of that 1 and put plus 0. I'm just going to not write it at all. So now that we have everything we need, we can find the derivative of y with respect to x by applying the quotient rule, which is f prime g minus fg prime all over g squared. So I'm going to write down everything that I have, substituting it in. So g would be x squared plus 1, and then minus f, which is 5x minus 2. G prime would be 2x all over g squared. So g, remember, is x squared plus 1, and the denominator has that g being squared. Remember to substitute in parentheses. I didn't put 5 in parentheses just because just one term, but technically I should. And then from here, it's just about cleaning up the numerator by applying PEMDAS, meaning multiply before you start to add and subtract in this case, because nothing to do with the parentheses. There's no like terms I can combine in there, and there's nothing I can do with the exponent. So we're going to start by multiplying, and this would give me 5x squared plus 5. And again, like I did in one of the previous problems, I'm going to put the 2x in the front just so I can distribute the negative and the 2x. So if I put the negative 2x in the front of 5x minus 2, if I distribute that, that would give me negative 10x squared, and then negative 2x minus 2 would give me positive 4x. So again, all I did was put the 2x in front of this parentheses, because remember, multiplying doesn't matter the order, just so I could distribute it in a more algebraically friendly fashion. And then from here, I'm going to bring down the denominator, which I haven't used at all because it's still going to simplify my numerator. So from here, I'm going to look for like terms to combine now that I've distributed everything, and now I'm just going to add and subtract. So 5x squared minus 10x squared would give me negative 5x squared. The 4x, there's nothing with x, so I'll bring it over. And then constant plus 5, nothing there as well, so I'll bring that over. And then over the denominator, which I haven't used at all, which is x squared plus 1 squared. And that's it. That is your derivative. If you want to further expand, you can, but the only point of expanding it would be to simplify. See if you can factor out to divide out, but since there's nothing that could be factored out in the numerator, can't really divide anything out. So yeah, hope this helps, guys.